Okay, so here I am awkwardly trying to get. Okay, we did it. Look at this. This is great. All right, we moved on. We finished up with our innate immunity, and now we're moving on to what's called your adaptive, or your learned, or your specific immunity. There's just three different words for the same thing. I like specific immunity. I don't honestly know which IB prefers. The idea is that we're not just getting general barriers anymore. We're specifically targeting a particular pathogen. So here's how it works. Um, this is an old word, but it's come up again, and you need to revisit this word. The word is antigen. An antigen is a protein or a molecular marker on the outside of a cell. So all of your cells will have different antigens to tell your body, hey, I'm a skin cell, maybe don't kill me. Or hey, I'm a blood cell, maybe don't kill me. But the thing is that pathogens, such as this bacterial cell here, will also have antigens to communicate with each other, yeah? So that they don't want to kill each other. And so what happens is as a pathogen enters your body, your immune system can recognize the antigens on that pathogen and then learn to kill it. And that learning part is what we're going to talk about in this part of the lesson. So, new white blood cells. We talked about phagocytes, which are just general killers. But now we're going to talk about the white blood cells that can learn. And so these are the white blood cells that can produce antibodies. Those are known as lymphocytes. And there are lots of types, but for this course, we're going to focus on just B and T cells, which are both types of lymphocytes. So lymphocytes produce antibodies. This is an antibody. It's just a protein. It's a little Y-shaped protein. And what happens is on the end of that Y-shaped protein, there's a very specific sequence of amino acids, which are built to match different types of antigens. And so antibodies are proteins designed to attack a specific pathogen because that pathogen will have antigens that match with the antibody. And so your immune system can learn which antibodies can appropriately attack specific pathogens. And so the antibodies are going to have a specific match to a certain antigen. And here's how that works. Many antibodies are what we call monoclonal, which means that there's one type of antibody to attack one type of antigen. And the word monoclonal has two meanings. One is that the antibody is monoclonal, one type, and they also come from one type of parent cell that is making the antibody. So we have one type of cell making one type of antibody, all designed to attack one type of pathogen. So how do these cells know which type of antibody to produce? It's a little weird. So, oh my god. Here we go. So let's do this. Let's say there's a microbe. We're going to call this microbe Gary. Let's say Gary, the microbe, gets through your skin, through your surface barriers, your mucous membranes. None of that works. Gary makes it into your cells, into your blood supply. It's in your body. What Gary's going to do is going to float around and just screw stuff up until your special blood cells called macrophage. So a macrophage is a white blood cell that will find Gary and gobble him up. It's going to swallow Gary whole. It's going to engulf Gary. So now Gary is inside the macrophage, a little freaking microbe. Okay. But what macrophages do that's kind of unique is they don't just gobble up the microbe. They're not just going to gobble up Gary. They're going to take a little piece of Gary, an antigen, and they're going to show that piece to their friend. Be like, look, freaking Gary's here again. Let's go get him, right? So they're going to take a little bit of Gary, this little antigen, going to show it to their friends. So now the macrophage has been sort of activated once it engulfs Gary. And once it goes through that activation process, we now call it a dendritic cell. But it's the same cell. It's the same macrophage. It's just now that it's activated, we call it a dendritic cell. And it has a little piece of Gary, a little piece of that microbe, a little antigen right here. And it's going to present that antigen to a T cell, another type of lymphocyte. And so now this lymphocyte knows that freaking Gary's here. and we got to go after all the Garys. Because, if there's one Gary, there's going to be more than one. Gary's coming together in groups, right? So this T cell's like going to have to start to get all of the army together to go fight Gary. So the T cell has now been activated, and it's going to communicate with what we call a B cell. Now, this is where things get weird. So these B cells have been waiting in your body the whole time. They're like, they've got a vendetta, and they're like, oh my God, that Gary. If that Gary ever shows up, we're going to get him. And so they've been waiting inside your body in lymph nodes, more on that in a minute, just in case Gary ever shows up. And now the T cell's like, yo, Gary's here. So the B cell is activated, and it's ready, and it knows that Gary's afoot. And so what the activated B cells are going to do is they're going to start to clone themselves and make more anti-Gary cells. These are called plasma cells, right? These clones are called plasma cells. And the plasma cells, their whole job is just to make a ton of antibodies, all of which specifically target Gary. So let's do it again. Microbe gets in, macrophage gets activated, presents the antigen to a helper T cell. The activated helper T cell finds a specialized B cell that already knows how to fight off Gary, clones it. Those clones all make antibodies specifically designed to mess up some Garys. So that's the process. Now, I hope at this point you're wondering, okay, how did this B cell know how to fight Gary? Well, this is where things get really weird. There's this concept called clonal selection. And I hate this. God, how do I get rid of myself? And the idea with clonal selection is, and again, this is weird, stay with me. As you're developing as an embryo, little baby you, your white blood cells, your immune system starts to make just random varieties of B cells. Just a bunch of random B cells. And they just hang out in your body. They're hanging out in special parts of your body called lymph nodes. They look kind of like this. So you have countless types of lymph nodes, which were all made as you were developing before you were born. And then, as the development continues, you just make more and more and more and more types of B cells, including B cells that could attack your own cells. So then what happens is your body starts to kill off any B cells that might be attacking your own cells. And then everybody that's left over should be built to attack foreign cells, right? Because they don't, you've killed off all of your self-attacking B cells, leaving only B cells that are designed to kill pathogens. Now, let me back up a little bit. This step right here, the body then kills off any self-attacking cell types. If you have an autoimmune disorder, that's because this process did not happen properly and you retained some of those lymphocytes that accidentally were built to attack your own cells, and that's going on. Your immune system attacks its own tissue. It's not good. But what's supposed to happen is all of those self-killing cells should be gone, leaving you with only B cells that are ready to attack pathogens. And all of those B cells hang out in your lymph nodes. So we have all these different varieties of B cells just waiting, just in case that matching pathogen shows up, and they wait inside your lymph nodes. Now, as you're infected, the T cell finds just the right B cell that's already waiting in the lymph node, and it starts to get cloned to make plasma cells. And those plasma cells are already built to make the right antibody to kill the infecting pathogen that got there. And so as those plasma cells start to develop, these lymph nodes start to swell. So your tonsils are lymph nodes. They swell because of all of these plasma cells that you're cloning, and it just gets full in this lymph node, and it kind of hurts and it swells up. So going back through this process here, Gary's here, macrophage is here, dendritic cell, T cell, activated T cell finds the B cell that was already there in your lymph node. That B cell then gets cloned a million times, making all these plasma cells, swelling up your lymph nodes. Those plasma cells then go through your lymph system, out to your blood supply, and go off and just kick ass. They go and they attack all the Garys that might be in your body by making antibodies. Okay, so just FYI, your lymphatic system is a series of lymph nodes. All these little green dots are lymph nodes. The spleen is actually a giant lymph node. These are the cervical lymph nodes, including your tonsils. And they're all over your body, and they all have naive B cells just sitting there waiting to be activated to then go off and produce plasma cells. Okay, so those plasma cells, as I said before, they're monoclonal. So they make one type of antibody, and those antibodies basically go off and they kill off the pathogen. But in addition to that, you will also make the plasma cells, you'll also make memory cells, which are basically the same thing, but they don't die. So instead of like fighting off the infection and going away, these hang out for sometimes decades. And they are called memory cells because they remember the pathogen. So they are going to be like, if Gary ever shows up again, we'll be ready for him, right? And it's those memory cells that get activated every time you get a vaccine. So what the vaccine does is it doesn't get you sick, but it gets you just sick enough to activate the right T cell, which activates the right B cell, which produces memory cells to help you fight off infection in the future. So all of that put together is how your cells make a specific immune response. So to see if you have the notes to get through a typical IB question, see if you can get through 8 marks explaining how infection by a pathogen can lead to an adaptive immune response. So obviously pause the video here, and when you're ready, the answer key is on the next slide. So pause me, try your answer. Okay, here's the answer. Okay, go ahead and check your answer, see how you did. This is a pretty good amount for one lesson. So while there is a little bit more, we have to talk a bit about antibiotics and stuff. I think we're going to save this for next time, and we'll just pause here. So make sure your notes are good. We're not re-lecturing on this. This is it. But do prepare questions that you have for me. Questions should not include what is an antibody, but more like, specific questions, things you missed. And we'll meet up next week, and hopefully this was a good start. All right. Bye. See, now I'm trying to hang up again, and this is awkward. Where's the